give you homework last time, and Hannah already reminded. Today, and the question is number. Which number, Hannah?
Number 6.
Number 6. Show that every group of order 45 has a normal subgroup of order 9. Can you raise your hand if you have done this? I just want to see. Can you give a thumbs up if you have tried? I hear my phone. No thumbs up at all? Nobody? Nobody tried? Or you cannot try? Or you don't have time? Or you forget? Which one? Amtina, I cannot hear you. You have to unmute.
Don't have time, Doctor.
You don't have time.
I have a lot of homework.
Okay. What about the others? You forgot? Hannah, you cannot forget. Because Hannah is the one reminding. I mean, it's okay. I'm just asking. I'm not asking you to like stand up on your desk because you don't do your homework. Or go sit in the corner because you forget your homework. I just want to know if you have try or no, because I can understand every class probably you have homework or there's something due. Some of you PhD students, let me silence this I forgot again. Notification, turn off. Mute, okay. Okay, because sometimes I know that you have other things to do. If you register here for grade, then it is compulsory for you to take all because there's grade for you. For the others, some of them they're doing just research, but this is the opportunity to learn because probably you won't have the chance to take any official classes if you have to teach. But some of them, they are having like presentation and so on. If you have time, it's good actually. That's why I just give you. If no, then I will go over it. That's why I ask. You don't need to be scared. I don't bite people or that I don't eat people. So I ask again. If I don't see any thumbs up, meaning nobody has tried this. So let me ask again. Did any of you have the time to try? Okay, no. Okay, then we can do this together. Okay, so let G be the group, right? Okay, we let G be the group. Hey, why is it subgroup? Anna? Group, right? I say group, but I write subgroup. Show that every group of order 45 has a normal subgroup of order 9. It didn't say use Sylow theorem, but we are in this chapter. So let G be a group of order 45. Write this in terms of product of primes. 3 squared times 5. 9 times 5. Okay? Now the question is to show has a normal subgroup of order 9. So you see that Sylow 3 of G is the one that has order 9. Because Sylow 5 of G, the order is 5. Okay? All right, so we try using Sylow's third theorem. So N Sylow 3 of G is 1 mod 3, and N Sylow 3 of G divides 45. Hassan, how are you? Are you there, Hassan? Okay, Ain, can you give me the factors of 45?
1, 3, 5, 9, 15, and 45.
This? Right? 1, 3, 5, 9, 15, 45. Okay. You don't multiply here, yeah? You just multiply. All right. So which one is 1 modulo 3, Ain? This is 1.
Just 1.
0, 2, 0, 0,
0.
If it is divisible by 3, then it is 0, right? So, N Sylow 3 of G is, 1. So, N Sylow 3 of G is normal in G. And N Sylow 3 of G, or the Sylow 3 of G has order 9. So you need to conclude, thus, every group order of 45 has a normal subgroup of order 9. This is order 9. So thus, every group of order 45 has a normal subgroup of order 9. Okay, conclude. Thus, I can say a group of order 45, is it simple or not? It's not simple. There is another way to ask the question. Okay, because there is this normal subgroup, so it is not simple. Okay, I want to do another one. Number 7. Okay, number 7. I give you 5 minutes. 5 minutes. Now, do number 7. Show that there are no simple group of order 2 by 5. Okay, so let G be 255 5 times. It's 5 times
3 times 17.
3
3
times
5 17. 5 17.
Then we have Sylow 3 of order 3, Sylow 5 of order 5, and Sylow 17 of order 17. Okay, now we try to calculate, yeah, by Sylow's third theorem. Okay, and Sylow 3 of G is 1 mod 3. Yeah. And N Sylow 3 of G divides 255. And what are factors of 255? 1, 3, 5, 15,
17,
17,
51,
51,
85.
85, 255. Okay, so 1, 3, 5, 15, 17, this, and the whole one. Okay. So which one is 1 mod 3? This, right? 0, 2, 0, 2. One, 0.
Bukan zero.
One. Here ke 1? So this one is 1. Anna?
Yes, one.
So 1, 51,
51 tu zero.
0. Okay. 1, 85. Okay? Next. And Sylow 5 of G is 1 mod 5. And N Sylow 5 of G divide to 5, 5. Again, we go through. So N Sylow 5 of G, 1 is always 1. Now 5, yeah? This is 3, 0, 0, 2, 1. 0, 0. Okay? So N Sylow 5 of G is 1 or 51. Okay, last one. Last one is 17. 17. So N Sylow 17 of G, 1. This is 3, 5, 15. Okay, they're all less than 17. This and this, 0, right? Because this is 3 times 17. This, 0, because this is 5 times 17, 0. So, only 1. And so finally, thus, Sylow 17 of G is normal in G. So, G is not simple. So there are no simple groups of order 255. Okay. So if you answer only here, because I only look at this one, but we go through one by one, right? This one you don't get any marks because the only mark come from this one. But if you don't try, we don't know, right? So you just have to go through. Okay. Sometimes the answer don't give us the one. Okay, let me see. Let's try another one. Number 11. Did we do 11? Not yet, right? Okay, number 11. Show that. Hannah, can you read it? Number 11.
Show that every group of order 56 has a proper non-trivial normal subgroup.
Okay, so this says also that a group of order 56 is not simple. That's another way of saying it. Okay. Let's try do it again. Let G be 56. Empty null?
Choose 2 plus 3, 7.
Okay, because it's 8 times 7. Okay. So we have Sylow 2, empty null of order
8, doctor.
okay. And Sylow 7,
7.
7. Okay. So by Sylow's third theorem and Sylow 2 of G, 1 mod 2 and Sylow 2 of G divides 56. Empty null? What's the factor of 56?
1, 2, 7.
7.
Yeah.
1, 2, 4, right?
Yeah, 4. 4. 4.
Okay.
4, 8.
Okay, 1, 2,
4,
4,
8.
7,
7, 8.
8,
Yeah.
14,
14. 28.
28,
56.
56. If you miss even one, it will affect your answer. Because probably when we choose, right? Okay, which one is 1 modulo 2?
1. 7.
7?
Yeah.
Done.
Hmm.
Only odd.
1 and
Okay, only odd. So I write here, and Sylow 2 of G, 1 or 7. Okay, now I change, yeah, to 7. Okay, so and Sylow 7 of G, 1, empty null,
1 and 8.
1 and 8.
Yeah.
This is modulo 7. So 2, 4, 0, 0, 0, 0. 1 or 8. How do you show that it has a proper non-trivial normal subgroup? Because you
Not
have
equal
these
1.
possibilities. How do you show? So we have actually 4 possibilities. Okay. Case 1. And Sylow 2 of G and Sylow 7 of G, right? So the first case is if this is 1, this is 1, right? The second case, if this is 1, this is 8, right? 1, 1, 1, 8. The third case is when 7, 1, right? Or the fourth case is 7, 8. Okay, because we don't know, right? Is it this or this? If you give me the group, then I will know. Like last time, remember when I said S4, then there are 3 subgroups of order 8 because we know, we can list, but this we don't know. There's possibilities. Okay, now you tell me, in any of this case, do you have a normal subgroup? Okay, in each of these cases, do you have a normal subgroup? So if there is this case, this is the normal subgroup, right? Order 1. So Sylow 2 is normal and Sylow 7 is normal for this case. For this case, Sylow 2 is normal, right? For this case, Sylow 7 is normal. For this case, not normal, right? Sylow 2 is not normal. Sylow 7 also is not normal. So you see, the only case in which G has no proper non-trivial normal subgroup is if we have this case. Okay, so what we have to show is this case is impossible. Okay, this case is impossible. If this case is impossible, we will have this only. And each of these 3 cases, we have something normal. So this is what we have to show. Okay. To show the fourth case is impossible. Okay. You understand, right? So we have 4 cases. Each of the case will have a normal subgroup except for 1. So what we have to show is the fourth case is not possible. All right. So we have to, I can erase, right? Okay. Okay, now suppose n Sylow 2 of G not bersin. I was about to sneeze, but stop. What is the number again? I erased, I forgot. Hannah, what's the case? 7 and 8, right? Yes. Okay. So suppose we have the fourth case. Suppose n Sylow 2 of G is 7 and n Sylow 7 of G, 8 of them. Okay, you remember? Remember this before I move on and count. I do the counting. Yeah? You remember S3? Right? You have 6 elements. You have 6 elements. Let me put this. Oh, yes. Okay, you have this. Wait, let me think. No. It's not this. This is not partition, sorry. It's like this. You remember the Sylow subgroup, okay? I draw a flower. Can you see this? You remember? Right? You remember we have 3 Sylow 2 subgroups, and then we have 1 Sylow 3 subgroups. Tan, you remember? Tan, you remember you asked me what happened to the other one? I said they are the same. Okay, so for S3, you have 3 Sylow 2 subgroup of S3, 3 of them. And you have 1, the number, right? Let me write like this. And Sylow 2 of S3 is 3. And Sylow 3 of S3 is 1. Okay, so we have 3 Sylow 2 and we have 1 Sylow 3. They are subgroups. That's why we call it subgroups. Sylow P of G is a subgroup of G. Okay, so since it is a subgroup, the identity has to be inside all the subgroups. Okay, so you see there's identity here. That is why I put here. They have a common identity inside. There's a 1 inside. And for these 3, oh sorry, is here, is here, is here. And for this 3. Okay, and when you count 1, 2, 3, 4, 5, 6, you get the whole elements. Okay, this is how we count the number of elements in the Sylow subgroup. So when I count the number of elements, in this case, these are the only subgroups of S3. But the Sylow subgroups are not the only subgroups. There might be other subgroups because Sylow subgroups are only the highest power of P, right? Whatever P that we have. We might have other subgroups. So if you remember S4, okay, before I do this, what? No place to erase because I need all. Let me do this and then I erase, yeah? If you remember S4, right? This is 2 cubed times 3, right? The Sylow 2 of S4 has order 8 and the Sylow 3 of S4 has order 3, okay? So these are not the only subgroups of S4. You have subgroups of S4 of order 2 and also of order 4. So there are many other subgroups, but the highest P power is the Sylow subgroups. Okay, don't forget this, okay? Sylow subgroups are not the only subgroups. You can have many other subgroups, but the highest P power order is called Sylow. So you have subgroups of order 8, you have subgroups of order 3, you also have subgroups of order 2, but it's not Sylow subgroups, the name is different, and order 4. Okay, my point is When we count, then you can see why I put this. Okay. My point is, it's not the only subgroup. But in this case, yes, because you don't have any other subgroup. The Sylow subgroup is actually the subgroup generated by elements of order 2 and elements of order 3. Now I want to count. Count the number of elements. Okay. How do I count? 3 of them, so it's 3. Okay. 1 plus 1 is the identity. The identity. 3, because there are 3 of them. And how many inside is the order? The order is 2. The order is 2 minus 1. Minus 1 because of the identity. Right? So I have 3 of them. I have 3 of them. 3. I have to count only this. So 2 minus the identity. Plus 1 of them. And the order is 3. Minus the identity. Okay? And you get this 2. So, count. You get 1 plus 3 plus 2, which is 6. So in this case, it's exactly 6 because you don't have any other subgroup. Now we go back to our problem here. Okay, I will do the counting. Remember, we want to find the contradiction. So the case is impossible. Okay, I erase, yeah? Okay. Okay, now do the counting. Okay, how many? 7. 1 plus. Okay, 1 plus 7. Sylow 2 is order 8. So 8 minus 1 plus Sylow 7. 8. 7 minus 1. Okay. So this is the number, which is 7. Sylow 2 has order 8. Don't forget, it's the highest power. Plus 8, how many of this? Of order 7 minus 1. So this is 1 plus 49 plus 48, right? Which is equal to 98. Who's not inside? Hmm?
Wali and also Hassan.
What happened to Wali and Hassan? Right? Suddenly, maybe the internet. You don't kick anybody out, right? Hannah? You don't kick them. Okay, is this possible? The subgroup is order 56. When you count only these 2 subgroups, this is more than 56. So this is impossible. Right? This means you cannot have the 4th case. So you cannot have the 4th case. So you will say that the 4th case is impossible. Okay, meaning, what does it mean? Since the 4th case is impossible, we have case 1, 2, or 3 in which there is a normal Sylow P of G. Because in each of these case, we have list, right? We have listed that in any of the case, there will be a normal. Sylow P, subgroup of G. So you conclude every group of order 56 has a proper, non-trivial, normal subgroup. Okay, so the counting is all right. Okay, let me see. No assignment due, right? Okay.